So here's our truth table in T flip-flop. So here, if our clock is 0, then T is 0, then Q is 1. So nothing retains previous state. Then Q bar is 0. Then if our clock is 1, then T is 1. So it toggles the previous stage. So it means that previous state is 1 is 1. So then output natin is 0. Then our Q bar is 1. Then if our clock is 0, then T is 1. So nothing retains from previous state. So our Q is 0, then our Q bar is 1. Then if our clock is 1, then T is 1. Then it goes the previous stage. So which is 0, then now the next state is 1. Then our Q bar is 0. Then if it is 1, 0, then so nothing retains previous stage. So not toggling. So not toggling 1. So 0. So our Q is 1, then Q bar is 0. Then here's my code. So I named my module as T flip-flop with 2 inputs and 2 outputs. So parang reg para sa store sa value. So nag-initial tadre Q is equals to 1, then Q bar is equals to 0. Then always add, then nag-post edge clock tadre. Then natin gamit is if else statement. So if clock is equals to true, then i-check nato ang value ni T. If T is equals to 0, then RQ is less than or equals to Q. Then Q bar is less than or equals to Q bar. Else, if dili ganit 0 atong T, then RQ is equals to not Q. Then Q bar is less than or equals to not Q bar. Then here's so sa ato running truth table. So output reg T clock. Then here's our dump file. Then kani is nag-base rata ani sa atong truth table. Then our test bench. So let's try to run it. Since we didn't have error, so we can proceed to our PVP. Then for our GTK wave. So for our input clock and T, then output Q and Q bar. So let's compare it to our truth table. So if our clock and T is equals to 0, so RQ is equals to 1, then Q bar is equals to 0. Then if our clock is equals to 1, then T is equals to 1. So RQ is 0, then RQ bar is 1. Then if our clock is 0, then T is equals to 1. Then RQ bar is 0, then Q bar is 1. Then if it is 1, then 1. Then RQ is equals to 1, then RQ bar is equals to 0. Then lastly, if our clock is equals to 1, then T is equals to 0, then RQ is equals to 1, then Q bar is equals to 0. So that's all for the Verilog code of our T flip-flop.